بسم الله الرحمن الرحيم. اليوم نبتدي محاضرة جديدة واستكمالا لمقدمة للنظرية الإلكتروديناميكية. اليوم نتحدث عن الفيكتور أناليسيس بكونه نحتاجه في حل مسائل الإلكترودينامكس. The first of these operators, it is the gradient, which is its simple del. Its name del nabla or grad. We must be taking these operators in rectangular coordinates, cylindrical coordinates, as well as spherical coordinates. The first one, A, we can write the gradient in rectangular coordinates. Which is x, y, and z. Del equal partial x, x hat, plus partial y, y hat, partial z, z hat. These unit vectors can be written as I hat, which is equal x hat, equal a sub x hat, equal n sub x hat. All of these, it is unit vectors of x-axis coordinates. If we have a scalar vector field, scalar field likes phi, the del of phi equal the partial phi over partial x, x hat, plus the partial phi over partial y, y hat, plus the partial phi over partial z, z hat. Now we want to write the del or the gradients of scalar field in cylindrical coordinates. Which is r, phi, and z. Sometimes r is exchanged by rho. The del in cylindrical coordinates is equal the partial r, r hat, plus 1 over r, partial phi, phi hat, plus partial z, z hat. In spherical coordinates, which is r, theta, and phi. The del or the gradient we can put in this scalar field like phi, and phi. In spherical coordinates, it is the partial r, r hat, plus 1 over r, partial theta, plus 1 over the partial phi. Theta hat plus phi hat. And if we take in the phi in spherical coordinates, partial over partial r for phi r hat plus 1 over r partial phi over partial theta hat plus, I forget the index, which is 1 over r sine theta for the partial phi over partial phi. Phi